Hello and welcome everyone to this video. This is the second lecture on the series of mixtures and solution. So before we move on to this video, let me be very clear about this, that if you have not gone through the first mixtures video that we had done probably a couple of days back, you must go through that, and please find in the description of this video the link for that particular mixtures and solution part 1 video, so that you are clear in terms of what am I going to talk about. So some of these questions when I'll be doing in the session today, I will be using those things that I had conveyed in the last class. So ensure that you are thorough with all of those. Now in this video, what we'll be dealing with is the set of questions wherein you have specific removal and replacement cases. That means you have a type of solution, from there something has been removed and something has been added. Now this process may be repeated 4 times, 5 times. All those variety of questions are something that we will deal with in the session today. Now the general perception about this particular topic in the minds of the students is that this is slightly more tricky topic, because they take the conventional approaches to talk about it, or rather I would say the conceptual clarity is not till the level which is required to crack these questions on the paper, right? So that is something which is very, very important, that you must be clear with the concept rather than depending on the formulas. I've been saying this on every single video that I've done in this 100 days to CAT 2021 series, that you really need to understand this thing, that your formulas are not going to help you on any of the aptitude papers for that matter. It's about applying the concepts. So please ensure that you are thorough with the concepts. So in this video, we will be dealing with questions where you have got things being removed, a certain part of the solution has been removed and replaced by a certain thing. That process has been probably done 2-3 times, or you have different solutions being mixed with each other, and then there are certain amount of things that are getting replaced. All of those varieties of questions that we'll be dealing with today, right? So let's get into the video and try and understand the concept of removal and replacement. Now this concept of removal and replacement is based on a very, very simple observation. That's it. So I would not even want to call it as a concept. It is a simple observation. If you hold on to the example that I'm going to talk about, you will never struggle with any of the questions on removal and replacement. So let's have a look at this. Let's say, suppose I have A liters of pure milk available with me, and to this I'm adding B liters of water. So my entire solution will become what? A plus B liters. So let's say, suppose it is 10 liters of milk. I'm adding 5 liters of water to this. So the total will become what? 15 liters of milk and water solution. Of course, this is a homogeneous solution. That means any part that you pick out of this solution is going to be having the same ingredients as that of any other parts that you pick, right? So A plus B is the total quantity. Now let's say, suppose from this total quantity, I remove 10% of the solution. I'm removing what? I'm removing 10% of the solution. So let's say, suppose from anything, if I remove 10% of itself, then I'll be left with what? I'll be left with 90% of that particular substance. So if I remove 10% of the solution, please understand this thing. I'm not, as of now, not saying that I'm removing 10% of A alone or 10% of B alone. I'm saying as a mixture, from this, I'm removing 10%. So I should be left with a total quantity of 90% of A plus B. Now watch it a little more carefully. You will realize this is 0.9A plus 0.9B. That means if I am removing 10% of the overall solution, please understand this thing, that I'm removing 10% of whatever total quantity that was present over here. Okay, not 10% of the quantity of milk or water for that matter, right? So I'm removing 10% of the overall solution. This effectively means what? This effectively means that I have removed 10% of the individual ingredients. So look at A, that was the quantity, and I've removed 10% of that. So it has become 0.9 of A. Same way, B was the quantity over here, and I've removed 10% of that. That implies that we are left with 0.9 of B, right? Now, this is the only concept that is there. Now, there are a few things that I want you to pay attention. First, I'm only talking about removal at the moment. So I have removed 10% of the quantity, and then what am I left with is something important to observe with respect to each of the ingredients. Okay. Now, the next important thing that I want you to understand is where and all can an examiner create challenges for you. Okay. And I'm going to take you through those 3 challenges those are there in my mind. And I think if we are comfortable with those 3 challenges, then we will be able to sail through any of these questions which are there on any of the aptitude papers for that matter. Now, first challenge, The first challenge that I want to bring to your notice is this 10%. They might not give you a figure which is as easy as 10%, and you can very quickly get down to 0.9. Now, to be able to resolve this issue, let us evaluate this 0.9. What is this 0.9? This 0.9 is effectively what? 1 minus of 10%. 10% as a fraction corresponds to what? 1 by 10 or 0.1. So you are doing 1 minus 10% of x, and that is how you are getting 0.9, right? So let's say, suppose if they say that I'm removing 5 liters from 12 liters, from 12 liters of the solution, or let's say suppose from 60 liters of the solution, sorry. So from 60 liters of the solution, I'm removing 5 liters. Then how am I going to do this entire thing? So understand this thing, 5 from 60 removed is what fraction removed? 5 upon 60, which is 1 upon 12 that has been removed. Now I can, in the similar fashion that I've written over here, I can actually write this as 1 minus of 1 by 12 times of the initial quantity, which was A in this case. And what will be the quantity of B in the solution after the removal? 1 minus 1 by 12 of B. So whatever is the ingredient over here and what is the quantity over here, A and B, I am removing that much fraction out of that. So what will be left over? So if I remove 10%, I'll be left with 90%. If I remove 20%, I'll be left with 80%, right? So if I'm removing 1/12, then I'll be left with 11 by 12 of A and 11 by 12 of B. So we need not to be hell-bent on converting it to a fraction like 0.9. There might be some of these figures wherein you might remember the reciprocal percentages, but those reciprocal percentages are not absolutely correct. When I say are not absolutely correct, what do I mean? For example, if I say 1 by 6, it is 16.66 non-terminating. So if you want to now use 16.66 alone, that will bring in certain amount of error to your calculation. So fractions are the safer way to go about rather than going by a figure like 0.9 unless you get a easy figure like 10%, right? So that's the first part of the problem. Second part of the problem is they may say that I am removing 5 liters from an unknown quantity. So let me say that they say that 5 liters has been removed from X liters. Now, in that case, again, what you need to do is very similar thing, that what fraction has been removed? You have removed 5 liters from X liters. So what fraction has been removed? 5 by X. So what should be left over? 1 minus 5 by X of the individual quantities. So this should be 1 minus 5 by X of the quantity A and 1 minus 5 by X of the quantity B must be the leftover thing, right? Leftover individual ingredients for that matter. Let's go ahead and let's look at the third challenge. They may say that I'm removing X liters from Y liters. They may not give you what has been removed from what. So once again, what am I going to say? I'm going to say that, look, X by Y is the fraction that has been removed. So what is the leftover quantity? 1 minus X by Y. So I will say 1 minus X by Y of A is the leftover quantity and 1 minus X by Y of B is the leftover quantity of that particular ingredient. So to sum it up, you really have to look at this value and understand what is the percentage with respect to the original total solution. Point number one. Point number two, you should know before removal of anything that how much are the individual quantities. So if I'm aware about these individual quantities, then I can, and I'm aware about this particular percentage or the fraction for that matter, I would be able to get down to the individual quantities after the removal step, right? So this is something that I want you to keep on your mind. Now I'm going to take a couple of examples and talk about the application of this particular concept that we've just seen on those two questions, and then the regular drill remains the same. That means I'll give you about 7 odd questions, some time to do each of these questions, and then I'll solve them on the screen. So let's have a look at the first example where I want you to apply this thing. Now let us understand what is happening over here. The question is that you have got a 20 liters of milk solution over here, pure milk. First step is you are removing 2 liters, and the second step is you are adding 2 liters of water to this. Now over here, what are we saying? Again, the entire solution will be 20 liters. Now, please understand, over here, I had said 20 liters of milk. Over here, I'm saying 20 liters of solution because it is no more only milk. It is the solution that you are getting. Now, the third step is remove 2 liters from this solution and add 2 liters of water to this. Then the next fifth step over here is remove 2 liters and add 2 liters of water to this. So every time I'm adding only water. Now, please understand when and at the end of it, what am I asking you? I'm asking you what is the quantity of milk left over and what is the quantity of water leftover. This is what I'm asking you. Now, let's try and apply the concept that we had spoken about. There were two important things that I told you at the end of that concept. One, you need to know what percentage fraction has been removed of the original solution, and before removal, what are the ingredients, what are the quantities of these ingredients. If I'm able to do that, I'm fine on that question. Now, I'm starting with 20 liters of pure milk. So let me hold on to milk as a quantity. I will discuss this point in a little more detail when we go to the questions as to what quantity do you pick up and do your question with, okay? Because there's a certain thing that if you are able to visualize, you will be able to pick up the right quantity to be able to apply this concept. And even if you pick up the other quantity, it's just that it might become slightly more tedious, but your concept, of course, is universally true. So 20 liters of milk, and I remove 2 liters of solution from this. So 2 out of 20, if I remove, that's 1/10 of the fraction removed. That means what will I be left with? 1 minus 1 by 10, or I can simply say this is corresponding to 10% removal. So the leftover quantity must be 90%. So I will take 0.9 of this. Remember, I have only done up to this. And what is this? Please watch my words very carefully. This is the quantity of milk. I am yet not concerned with water at the moment. Okay, I am only looking at milk as a quantity. Now, if I look at milk as a quantity, it is 0.9 into 20 after this step. Correct. Now, move on to the next step. It is the addition of 2 liters of water. Now, when I'm adding 2 liters of water to this, my quantity of milk will not change because it is only the addition of water. So 0.9 into 20 will be the quantity of milk. That means at this step, at this point, in this 20 liters, I have 0.9 into 20 as milk, and the rest of it is water, right? I'm still going to hold on to milk and then move on. So now this is the individual ingredient, one of the ingredients. This is milk. The other ingredient is water. Now you're removing 2 liters again from a total of 20 liters. So if you are removing 2 from 20, again 10% has been removed. So what are we left with? We'll be left with 90%. Sorry, we'll be left with 90%. So at this level, my ingredient was 0.9 into 20 is milk, right? And I'm removing 10%. So I'll be left with what? 90% of this as milk. Again, what am I getting? I'm getting down to the quantity of milk after this step, correct? What am I adding to it? I'm adding water to it. So of course, it will not change the quantity of milk in the solution. So in this 20 liters over here, this is the quantity of milk. Now I'm removing 2 liters. Again, the same 10% has been removed. So 90% would be the leftover quantity. You will take 0.9 of this. So 0.9 into 0.9 into 0.9 into 20 is the quantity of milk leftover finally. Because when I'm adding water over here, it does not change the quantity of milk. So in this 20 liters, this should be the quantity of milk. What will be the quantity of water? The quantity of water should be nothing but 20 minus of milk. 20 minus of milk should be the quantity of water. Correct. So this is how you apply the concept that I had spoken about on the previous screen. What have I done? I have only looked at the percentages removal with respect to the overall quantity of the solution. Point number 1. Point number 2, I have looked at every level what are the ingredients. That's it. So I can remove that much corresponding percentage from that particular quantity which was available to start with before the removal. Addition of water. So I am not holding on to the quantity of water. I am holding on to the quantity of milk, right? Let's move on. Let's look at one more example of this, and very similar example. I'm going to do some very small changes to this question, and then I will apply it once again. So I've changed the question on the screen. From this 20 liters of pure milk, I'm removing 2 liters as my first step, adding 2 liters of water, again 20 liters of solution, removing 4 liters, adding 4 liters of water, again 20 liters of solution, removing 6 liters, adding 6 liters of water. In this 20 liters, what is the quantity of milk and what is the quantity of water is what the question again is, right? Once again, I'm going to do the same thing. I'm going to start with the quantity of milk because that's what I had, 20 liters of pure milk. So I'm starting with that. As my first step, what am I doing? I'm again removing 2 out of 20. That's corresponding to 10% as a fraction, right? So I'll be left with 90%. So I'll take 0.9 of this. Again, watch my words very, very carefully, guys. This is the quantity of milk. I'm adding water. Does not change the quantity of milk. So this 20 liters of solution, removing 4 liters of the solution. 4 out of 20, if I remove, that's a 20% removal now. So the leftover quantity will be what? 80%. So I'll take 0.8 of this. Again, adding water does not change the quantity of milk. So in this 20 liters, this will be the quantity of milk. Remove 6 liters, 6 out of 20. If I remove 6 out of 20, that's 30% removal. So what are we left with? We are left with 70%. So I'll take 0.7 of this. This will be the quantity of milk. What will be the quantity of water? If I look at the quantity of water, that should be 20 minus of milk. If I can do this, I will be able to get down to quantity of water, right? So once again, a very similar example I have taken, and we had understood that what percentage has been removed with respect to the overall solution. Let's now move on, and I'm going to give you, of course, a certain amount of time to do these questions, and then we move on to the solution of that question. Okay, so the drill remains the same as that of our previous sessions. So let's move on and let's look at the first question. 1.5 minutes of time for you to try and do this. Take your time. – 30 seconds more for this question. Right. Let's have a look at question number 1 and try to do this. From a can containing 20 liters of pure milk, 2 liters is removed. So from 20 liters of pure milk, I'm removing 2 liters. So that's removal of 2 liters and replace it with water. So I'm adding 2 liters of water over here, right? Again, I'll get 20 liters of solution now. Then 4 liters of solution is removed and replaced with milk. This is something which is interesting now. So what are we doing? We are removing 4 liters, but now we are adding 4 liters of milk to this. Again, I'll be left with 20 liters of solution, and then 6 liters is removed. So I'm removing 6 liters and replacing it with 6 liters of water again, right? So I'm going to be left with 20 liters of solution. Now in this 20 liters, what is the quantity of water left in the solution? That's what the question is. Now let's get started with this. Again, the concept remains the same, that I'm going to start with 20 liters of milk. And now I'm removing 2 liters of water. I'm removing 2 liters of water. That means what fraction has been, 2 liters of solution. That means what fraction has been removed? It's a 10% fraction that has been removed. So the leftover quantity will be 90%, right? So I will take 0.9 of 20 as my quantity of milk leftover after the first removal. What am I adding to this? Water. Does not change the quantity of milk, right? Because it's pure water being added. So your quantity of milk remains the same, which was there after this step and which was this, right? Now at this level, you have got 20 liters of solution. Now you are removing 4 liters out of 20. So if I'm removing 4 out of 20, that means I'm removing 20% solution. So I will be left with what? I'll be left with 80% solution. So I'll take 0.8 of this, right? Now add 4 liters of milk to this. Now understand this thing. What have we done? After this 4 liters removal, what we have calculated over here, what is this quantity? This quantity is milk, right? And I am now adding 4 liters of milk. Should I not simply do a +4 to this? That is what makes sense. And keep things simple and understand every single step. You're fine on this. It required just a +4. That's it. Nothing more than that. Okay. So again, in this 20 liters, I have got this as the total quantity of milk available with me. Now I'm removing 6 out of 20. 6 out of 20 is 30% removal. So the leftover quantity will be what? 70%. So if I take 0.7 of this, I should then be left with the quantity of milk, because at the last step you are adding water again. So that will not make any difference to my quantity of milk, right? So in this 20 liters, this will be the quantity of milk. They had asked you the quantity of water specifically. So we will have to calculate this and subtract it from 20 to be able to get down to this. So we get what? 0.7 into 0.8 into 0.9 into 20 plus of 0.7 into 4, which is 2.8, right? So if I look at this, this is going to be 0.56 multiplied by 18 plus of 2.8, right? So this is going to be the solution. If you solve this, this will turn out to be in all probability 12.88. Let's not put in too much of a time in calculation. So this will be 12.88 as the quantity of milk. So what will be the quantity of water? The quantity of water will be 20 minus of 12.88, which is 7.12 liters of water will be left over, and 12.88 liters of milk will be left over after doing all of these steps. So 7.12 will be the answer for this question. Let's move on. Let's look at question number 2. Take your time, try this out. Another minute and a half's time. Last 20. Right. Let's have a look at this question. Several liters of acid were drawn off from 54 liters vessel full of acid, and an equal amount of water was added. We don't know how much is the quantity of acid being removed. We started with 54 liters of pure acid. We've started with 54 liters of pure acid. We are removing certain amount of acid and replacing it with an equal quantity of water. So suppose I'm removing X liters and I'm adding X liters of water to this. X liters of water to this. Again, I'll be left with 54 liters of the solution. Again, the same amount of mixture was drawn off and replaced by water. Again, the same amount of mixture has been drawn off and replaced by water. So again, I'm adding X liters of water to this. So again, I'll be left with 54 liters of solution now. And the vessel contained 24 liters of pure acid. This, out of 54 liters, you have got 24 liters of pure acid. That means water will be the leftover quantity, which is 30 liters. 30 liters of water will be there in this. Now, how much acid was drawn off initially? That means the value of X is what they're looking at, right? Now, I am starting with acid over here, right? Which is 54 liters of acid. So I'm going to take 54 liters of acid and say X liters has been removed. That means what fraction has been removed? X by 54 has been removed as a fraction. So what should be the leftover value? Leftover value should be 1 minus X by 54. So I'm going to do 1 minus X by 54 of 54 as my quantity of acid after this step. I'm adding water. So the quantity of acid will not change, right? So at this 54 liters of solution, my quantity of acid is present over here on the screen, right? Which is over here. Again, this is the quantity of acid, and from here I'm removing X liters out of the same 54 liters because it is 54 liters of solution. And of course, this percentage or the fraction that we are calculating with respect to the total quantity of solution. This is what we had discussed in the concept part. So X by 54 again will be removed. So 1 minus X by 54 of the ingredients will be left over after this step. And this was the ingredient. This was one of the ingredients, which was acid. So I'm going to do 1 minus X by 54 of this value. So can I then simply say that it will be the square of 1 minus X by 54 whole square multiplied by 54. That will be the quantity of acid left over after this step. I hope we all are clear as to y square, because I'm going to again multiply this entire value with 1 minus X by 54. So instead of doing that, I've made a square over here. And I'm adding water again. So that does not change the quantity of acid in this. So in this 54 liters, this should be the quantity of acid. Correct. And they have also given you the quantity of acid over here, which was 24. So that should be equals to 24 after everything has been done, right? So now can I equate both of them? I'll say 1 minus X by 54 whole square of this must be equals to 24 by 54, which is 6 4s are 24 and 6 9s are 54. So this is going to be 2 by 3 whole square of this. So can I then simply say that 1 minus X by 54 must be equals to 2 by 3? So if you solve this further, you will get X by 54 as 1 by 3, and X would then turn out to be equals to 18. Right? And what were they asking you? How much acid was drawn off initially? It was 18 liters of acid was drawn off initially. Now, I wish to bring a very important point to your notice now, because we have applied this a couple of times and we must be comfortable with the process of removal at the moment. Now we need to understand what quantity do we select and move on our question. Now, please understand this thing. Why am I selecting acid over here? Why is it turning out to be beneficial for me? Because the addition of water will not change the quantity of acid. That means this step present over here is turning out to be irrelevant for me in my calculation. And also this step is also turning out to be irrelevant for me in my calculation. I hope we all are okay with this. Now, that is the reason why taking acid is beneficial, because out of the total of 4 steps, 2 steps are irrelevant in my calculation, right? Wherein if you take water, because now if you consider water, this first step will be irrelevant because you cannot remove water. So your quantity will remain the same, which is 0. Now you are adding water. So the quantity of water will change. So this is one step where water will change. Again, when you are removing X liters of solution, again, water will change over here. So you will have to calculate water after this. Again, you are adding water, you will have to change the quantity. So you will at least have to do 3 times calculation over here. In the previous case, we were only doing it 2 times. And that is the reason why I'm holding on to acid and not water. So choose your quantity intelligently as to out of these steps, which step will not make a difference to a particular quantity. And I'll select that particular quantity because that reduces my work on the question. Okay. So let's move on and let's look at question number 3. Again, a minute's time to try and solve this. Take your time. Take about a 15 seconds more. Right. Let's try and solve this. 3 liters of water is taken out from a vessel full of water. So you have pure water and you are removing 3 liters from this and substituted by pure milk. So you are adding 3 liters of pure milk. right? So you'll get a certain quantity over here. This process is repeated 2 more times. Again, you will remove 3 liters and add 3 liters of milk to this. You'll get certain quantity. Again, remove the same 3 liters and add 3 liters of milk to this. So you'll get the same quantity over here. This process is repeated 2 more times. Finally, the ratio of milk and water in the resultant solution is 1701:27. It is the ratio of milk to water, remember. Find the volume of the original solution. So let me say that I'm starting with the original solution as X liters. So I'm starting with X liters of original solution. Now I'm removing 3 liters out of X liters. So this is the fraction that has been removed. So what will be the leftover fraction? 1 minus 3 by X. This will be the leftover fraction. So what is the quantity over here? I'm starting with water, right? And I'm adding milk. So if I look at milk, milk will change after every removal as well as addition. But water will not change because of this 3 liters of milk being added, right? So I'm going to start with water. So I'm saying I'm starting with X liters of water. And I'm saying 1 minus 3 by X will be left over, as 3 by X is the fraction that has been removed. So the leftover quantity should be 1 minus 3 by X. So I'm going to do 1 minus 3 by X of X. Now go further. Again, this is the quantity of water. You are at this level because addition of milk is not making a difference to that. Now I'm removing again 3 liters. So the same fraction has been removed. So the same fraction will be left over. So again, now I'm going to do the square of this and say that this will be the quantity of water left over after this step. Correct? Now adding 3 liters of milk does not make a difference to my quantity of water. So this will be the quantity of water at this step. Now again, I'm removing 3 liters. So 3 by X will be the removed fraction. The leftover fraction should be 1 minus 3 by X, right? So I will take 1 minus 3 by X of this value. So let me write it over here. 1 minus 3 by X of this value, right? This will be the quantity of water left over after this step. Adding milk does not change the quantity of water. So at this level, this is the quantity of water left over. And what is that they're saying? They're saying that milk to water ratio is 1701:27. So what will be the quantity of water? The quantity of water will be 27 parts out of a total of 1728 parts. Of what? Of X. This should be the quantity of water left over. So if I equate this, X will get cancelled out. Over here, what we will have? 1 minus 3 by X whole cube of this should be equals to 27 by 1728. Now, when you look at any such figure, you should try and think in terms of how can I make it a cube? Otherwise, solving this will become very difficult. Also, 27 gives you a fair idea that this is 3 cube. So if you look at 1728, that will become 12 cube. So you can simply say it is 3 by 12 cube, which if you try to solve it further, will then turn out to be 1 minus 3 by X is equals to 1 by 4, as 3 by 12 is 1 by 4. So you will get what? 3 by X is equals to 3 by 4. 3 will get cancelled out. What are we left with? We are left with X equals to 4. What is the question asking you? Find the original volume of the solution. Original volume of the solution must be 4 liters. And why liters? Because this was in liters, right? So this will be the answer. Guys, trust me on this. If you do this with about a 10, 12, 15 questions back to back at a stretch, you would realize that this will become very easy for you. You will not require so much of a time to do this without putting any formula to your mind. That is something which is very important. Let's move on and let's look at question number 4. Again, a minute's time to solve this question. Take your time. A 15 seconds more. Right. Let's try and work through this. From a solution containing milk and water in the ratio 9:7, what fraction must be removed and replaced with water to get a resultant mixture of 1:1 milk and water, right? From a solution containing milk and water in the ratio of 9:7. So let's say, suppose I have a total quantity X. Now watch it very carefully. What am I doing? I'm saying there is a total quantity X. From there, I'm removing Y. Okay. So what fraction must be removed and replaced with water? So I'm adding Y liters of water to this. This is a milk and water solution that we are getting over here. Finally, I should get X quantity because I've removed Y liters and added Y liters. So I should get X quantity. Now in this X, 1:1 is milk and water. So can I then say that half of X will be milk and half of X will be water? None of this is something that I've derived as of now. All of these things were given to me on the question. I've just introduced two variables, X and Y, right? To start with, the milk and water ratio was 9:7. So can I say over here 9/16 of X was milk and 7/16 of X was water? Now think about it. You are adding water. So water will change over here when you are adding this. And for removal also water will change. So I will not start with water. I will start with my quantity of milk. So I'm going to say 9/16 of X is the quantity of milk to start with. Now, what am I doing? I'm removing Y liters. That means what fraction has been removed? Y by X has been removed. That means the leftover quantity should be what? 1 minus Y by X, correct? So I can simply do 1 minus Y by X of this. 1 minus Y by X of 9/16 X should be the quantity of milk leftover, correct? After which step? After this step, correct? And I'm adding water. So the quantity of milk will not change. So this will be the quantity of milk after this step also. So that means finally over here, this should be the quantity of milk. And the quantity of milk, I can now get in the final solution also because the ratio is given to me in the final solution. So can I then simply say that half of X will be the quantity of milk, right? So of course, these two values must be equal. What is that they're asking you? What fraction must be removed? That means they're effectively interested in the value of Y by X. This is the value that they're trying to ask us, right? So can I just solve it for the value of Y by X is all what the question is. So 1 minus Y by X into 9/16 of X should be equals to half of X. So X will get cancelled out. 2 8s are 16. So 1 minus of Y by X should be equals to 8 by 9. So what we will get? 1 by 9 is equals to Y by X. And that is what they were asking you. So that's the answer for this question. I hope we all are clear with this. Please understand this thing, guys, that if you are able to execute this for about a 10-12 problems at a stretch, hold on to the video, keep it in front of you, take about 10-12 questions from whichever material that you are referring to, apply the same concept again and again. If you do that for 10 odd times, you are never going to forget this thing for the rest of your life, for sure, right? Because this is pure concept. I have not given you any formula to do any of these things, right? Let's move on. Let's look at question number 5. Again, a minute and a half's time to do this. Might be slightly lengthy, so take your time. Take a minute more to solve this. Last 20. Right. So let's have a look at this question. A question coming from one of the CAT papers, very recent CAT papers. So it says a strength of a salt is P percentage if 100 ml of solution contains P grams of salt. Now let us understand one thing, that this has got nothing to do with the question. It is just explaining you what do we mean by strength. That's it. So you don't have to really read this statement again and again for any data, because you won't find anything over there, right? Each of these three vessels ABC contains 500 ml of salt solution with the strength 10%, 22%, and 32% respectively. Now 100 ml of solution in the vessel A is transferred to the vessel B. So you have a vessel A from which you have taken 100 ml of the solution, and vessel A had 10% strength, and you have put it into the vessel B, right? So let's try and just do this step. I have the solution coming in from A, which is how much quantity is coming in from there? 100 liters, 100 ml, right? And it has got 10% strength to this. Then I'm adding it to B. B has got what? 500 ml in it, and that strength is 22, right? So let me say that final strength after we mix these two is A percentage. Now, according to this, or rather, let me call this as P percentage, because A and B I've written over there. So I'm calling it as P percentage. Okay. Now, please understand this thing, that this is something which is coming from the mixtures and solution part 1 video, right? So what am I going to do? I'm going to say that 10 is lower, 22 is higher, so 22 will create a surplus. What are we going to do? 22 minus P into 500 must be equals to P minus of 10 into 100. Let's just solve this. So what are we going to get? We will get 110 minus 5P should be equals to P minus of 10. That means it will be 6P equals to 120. That means P must be equals to 20%. P must be equals to 20%, right? So now what are we saying? So now you have the vessel B that contains 600 ml of solution and has got 20% strength in it. Now go further. Then 100 ml from the solution in the vessel B is transferred to the vessel C. So now I'm taking it from B. I'm taking how much? 100 ml, but this 100 ml will be 20% strength, right? Putting it in C. C was 500 ml, right? And C has got a strength of 32%. So let me say that this is Q percentage at the end of it, right? Of course, 32 is greater, 20 is lesser, so 20 will create a deficit. I'm going to do Q minus of 20. On one part of this, I've taken 100 parts of the solution. So multiplied by 100, total deficit. And what will be the total surplus? 32 minus Q into 500. So what are we going to get? We will get 5 over here. So we will get Q minus of 20. That should be equals to 160 minus of 5Q. So that's going to be 6Q equal to 180. So Q will be equals to 30%. So now you have a vessel C, which has got 30% strength and 600 ml of the solution. Now what are we saying? Finally, 100 ml of solution from the vessel C. So you are taking 100 ml from the vessel C, which is at 30% strength. So I'm going to take 30% strength is being put in A. Now remember this thing, A has not got 500 ml of solution. A has now only got 400 ml of solution because you had pulled out 100 ml from here. So you will put it by 400, and that strength was still 10%. Can I combine these two and understand how much is the final strength in the solution which is there in the beaker A, because that is what has been asked to me. So let me say it is R percentage. Of course, 30 is greater. So what am I going to do? 30 minus R into 100 is equals to R minus of 10 into 400. We just have to solve this equation. We'll get 30 minus of R is equals to 4R minus of 40. So 70 equals to 5R. R should be equals to 14%. So finally, in the beaker A, you will have 14% strength, right? Again, you might say that this question is difficult, but I would say that a single process has been applied 3 times. That's all. So if you're comfortable with the process once, then you just have to do it a couple of more times to be able to get down to the answer. So I don't really think we should struggle on this question once we read it. Okay. So let's move on and let's look at the next question. Take another minute's time to try and solve this. Take another 30 seconds. Right. Let's try and solve this. A vessel contains milk and water in the ratio of 3:2. The volume of contents is increased by 50% by adding water to this. So you are adding water to this and you are increasing the volume by 50%. So let's say suppose there was the volume X to start with. So your quantity of milk will be 3 by 5x and your quantity of water will be 2 by 5x. Now you are increasing this quantity by 50%. So that means X by 2 and you are adding that to water. So can I then simply say that 2 by 5x plus x by 2 will be the quantity of water, and what will be the quantity of milk in the resultant solution? 3 by 5x. Again, I can try and figure out a ratio for this, right? So if I take 10 over here, it will be 2, it will be 5, so 9x, and this should be 3 by 5x. Again, if I take the ratio, x will get cancelled out, 5, 2, 3. So you will get 2:3 as milk is to water as the solution after this step, right? Now go further. From this resultant solution, 30 liters is withdrawn. So you have a solution. Now the volume of that will be 3 by 2x as the total volume, right? And you are removing 30 liters from this. Of course, this 3 by 2x has got 2:3 as milk is to water ratio. Okay. So you are removing 30 liters from this and then replace it with water, adding 30 liters of water to this. The resultant ratio of milk and water in the final solution is 3:7. Finally, again, you will still get 3 by 2x over here as the volume. And this has got milk is to water ratio as 3:7. Find the original volume of the solution. That means they are looking at the value of x over here, right? So now, if you say 3:7 is the solution over here, what is the quantity of milk over here? It is going to be 3 by 10 of 3 by 2x. And what will be the quantity of water over here? 7 by 10 of 3 by 2x. Not difficult to figure this out. Also, to start with, over here, you had 2/3 as the ratio of milk to water. So what will be the quantity of milk? 2 by 5 of 3 by 2x. That will be the quantity of milk to start with. And what will be the quantity of water? 3 by 5 of 3 by 2x. Right? Now, we are looking at finding out the value of x. Now, again, I'm adding water to this. So water will change, right? So I'm going to start with milk as my calculations, right? So what is the quantity of milk that I have? 2 by 5 into 3 by 2x. From this, I'm removing 30 liters. So 30 divided by 3 by 2x is the fraction that is removed. So 1 minus of this will be the value of the fraction left over. So 1 minus of 30 divided by 3 by 2x is the fraction left over as the quantity of milk. Correct? And what is the quantity of milk? Finally, this is 3 by 10 of 3 by 2x. So the final quantity of milk is already something that we know, which is 3 by 10 of 3 by 2x. We will just have to equate all of this. So 1 minus of 3 by 2. So I'm going to cancel this and say it is 20 by x. 1 minus of 20 by x. I've just solved this fraction over here. 3 will get cancelled out. So you will be left with 10 and multiplied it by 2. So 20 by x over here multiplied by 2 by 5 into 3 by 2x. That value must be equals to 3 by 10 into 3 by 2x. This entire 3 by 2x will get cancelled out over here. 5 2s are 10. So what am I left with? 1 minus of 20 by x. 1 minus of 20 by x should be equals to 3 by 4. So 1 by 4 must be equals to 20 by x. X must be equals to 80. Right? So what have we done? We have started with 80 liters of solution originally over here. Again, you might call it slightly more lengthy, but I think that is the amount of work that you will have to do to get through a paper like CAT, if at all that is what you are writing, right? So let's move on and let's look at one last question for the day. Question number 7. Take a minute's time to do this. A minute and a half's time to do this. 30 seconds more to solve this. Right. Let's try and get through with this question. It says what a vessel contains 20 liters of milk and another vessel contains 15 liters of water. So you have milk over here, which has got 20 liters, and you have got water over here, which is nothing but 15 liters. 5 liters is removed from each of these vessels and transferred into another. So you are first going to pull out 5 from here, pull out 5 from here, and then put this 5 over here in this water and put this 5 over here in this milk, right? So after the first step, what will happen? If I look at the quantity of milk and water in each of these two solutions, then I'm going to get 15 liters of milk over here, 5 liters of water over here. What will happen over here? Milk will come from here. So you will have 5 liters of milk over here and you will have 10 liters of water. The total quantity will still remain 15 liters. And transferred into one another. The same operation is repeated once more. Now, this is where the task may become slightly more challenging. So you are removing 5 liters from here and then adding 5 liters from the other solution to this. So what are we saying? This is the total quantity 20. This will be the total quantity 15 liters, to which you will add 5 liters coming from this solution over here, right? So I'm going to say I have got 15 liters of the solution. In the ratio milk is to water as 3:1. Right? So 3/4 as the strength of milk in this, right? I am pulling 5 liters of water, 5 liters of another milk and water solution from here and putting it in this one, right? Over here, what is the ratio? 1:2. So what is the milk strength? 1/3. I'm going to take this strength as X over here and try and solve this to get down to the value of X over here. That will be the strength of milk in the first vessel. Right? So let's have a look at this. 3/4 is of course greater. So what am I going to make as the equation? 3/4 minus of X into 15 should be equals to X minus of 1/3 into 5. So we'll say 5 3s are 15. We will get 9/4 minus of 3X is equals to X minus of 1/3. So go further and solve this. We will get 4X is equals to 9/4 plus of 1/3. 9/4 plus of 1/3. So if I take 12 as the LCM over here, this will be 3, this will be 4, 27, 31, 31/12. So X will be equals to 31/48. Now 31/48 is the strength of milk. Then what is the ratio of milk to water in the first solution? The strength of the ratio of milk to water will be 31:17 as the ratio of milk to water in the first solution. So this is the first part of your answer. Let's look at the second solution. You will be left with 10 liters over here because 5 liters has been replaced in this. So you will be left with 10 liters over here and you are putting in 5 liters from this solution. This solution had 3:1 as milk to water ratio. So 3/4 will be the strength in this 5 liters. And in this 10 liters, the strength will be, the ratio was 1:2. So the strength will be 1/3. Let me take this final strength after mixing the two as Y. Of course, 3/4 is greater and 1/3 is lesser. So 3/4 will create a surplus. 3/4 minus Y into 5 must be equals to Y minus of 1/3. Y minus of 1/3 into 10. We just have to solve this to get the value of Y. This will be 2. So what are we left with? 3/4 minus of Y should be equals to 2Y minus of 2/3. So if we go further, we will get what? 3Y, which is equals to what? 3Y, which is equals to 3/4 plus 2/3. Let's just try and solve this. You will get 12 as the LCM. So multiplied by 3, multiplied by 4, 9 and 8, 17, which should be equals to 3Y, and Y should be equals to 17/36. So what should be this is the strength of milk in the final solution over here for the second vessel. And what will be the ratio of milk to water? That should be 17:19. That's the ratio of milk to water. So the answer to this question should be 31:17 and 17:19, right? This question would have become a lot easier if instead of having 15 liters over here, we would have had 20 liters, right? But a slight catch over there, please do not presume this to be a 20-liter solution and then try to do the question, okay? So that brings me to the closure of this video, guys. I hope you sit back at home and solve about 50, 60, 70 odd questions after going through the mixtures part 1 video and part 2 video, and then try to ensure that you score well on this particular topic in the paper, right? So that's about it, guys. Please do like the video and subscribe to the channel. If you're not a part of our 100 days to CAT 2021 program, then you can find the link to join that group in the description of this video. You will have to simply fill a form and we will add you to that group, right? So that's about it for this video, guys. Thank you so much.